mobilization phase, sometimes also known as mobilization phase. Then here you have to talk about this enzyme. Let us talk about the enzyme, the second enzyme, not highly controlled enzyme, of course, not regulated enzyme. You know, the enzymes that are involved in irreversible steps, that step 1, step 3, and the other irreversible step is the last step, where phosphoenol pyruvate converts to pyruvic acid or pyruvate. Then the three enzymes, here both enzymes, this and these enzymes are highly regulated. Even they are regulated by hormones, This and these are regulated by hormones, insulin and glucagon, Then sugar metabolism, the two hormones that are produced by pancreas regulate this, the conversion of glucose into glucose 6-phosphate, insulin and glucagon. Then this enzyme also highly regulated enzyme. But this enzyme, first I have to mention this enzyme. This enzyme is glucose isomerase. You can call it glucose isomerase because it is form of glucose. Glucose 6-phosphate isomerase. You can call it glucose 6-phosphate isomerase or simply glucose isomerase or glucose 6-phosphate isomerase. Isomerization reaction is not that important enzyme as far as regulation is concerned. Now, the third enzyme, the enzyme that is involved in the third step is phosphofructokinase 1. This is phosphofructokinase 1. If we do have phosphofructokinase 1, that means we do have phosphofructokinase 2 or 3 or whatever. Then I will tell you about how this enzyme is regulated in controlling this pathway. Now, one big event happens here, hereafter. One big event happens, this is reversible reaction, of course. Fructose 1,6-bisphosphate splits into 3 carbon isomers. And the enzyme that catalyzes is known as the aldolase. Then what happens? This is split or broken down into 2 isomers. One is glyceraldehyde 3-phosphate, and the other is dihydroxyacetyl This is keto sugar, and this is aldol sugar. Aldol phospho sugar. And this is keto sugar, phospho sugar. You see the event, this step is known as the fourth step. This enzyme is not regulated at all because it catalyzes reversible reaction. Therefore, these two can join to produce this by the same enzyme. What matters is concentration or the need of the cell. If the cell needs to change glucose into energy production, ATP glycolysis, if the cell needs to run glycolysis, it will catalyze the change of fructose 1,6-phosphate into these 3 carbon compounds. So the cell can generate ATP, pyruvate goes to link reaction proceeds citric acid cycle, then the whole process electron transport system, energy production, of course. This downward pathway is increasing production of ATP. But still, this reaction can come upward. It can come upward. These two can join to produce this. This can give this. Of course, the same enzyme is not used. There is another enzyme that catalyzes the conversion of this into this. That enzyme comes. This is inhibited. The other enzyme comes and activated to produce fructose 1,6-bisphosphate into fructose 6-phosphate. Then fructose 6-phosphate generates glucose phosphate, then glucose. This process, the important process is known as gluconeogenesis. Therefore, when we see glycolysis, we are talking of glycolysis, talks about the downward pathway where glucose is broken down into 3 carbon compound. Finally, the 3 carbon compound, which is the end product of glycolysis, is pyruvate. Okay, pyruvate. Therefore, so far we have seen. Look, I would like to focus on this process. Lysis. Look, the name, glycolysis, glycosugar. Lysis is splitting or breaking into 2 parts, lysis. Now, it seems that the glycolysis has got its name from this system. Exactly from this system, the 4th step. Because the 6 carbon phosphorylated, energetic, phosphorylated 6 carbon compound is broken into 2 3 carbon compound. If you like, glyceraldehyde 3-phosphate means it has this structure. Phosphate. Then this is aldo sugar, aldehyde functional group. Aldo sugar. Glyceraldehyde 3-phosphate means 1, 2, 3. Glyceraldehyde 3-phosphate, this the compound abbreviated by this. Like this one is keto sugar, 3 carbon compound still. Keton, that is carbonyl functional group, OH, H, O, phosphate, hydrogen. Therefore, this is keto sugar, phosphorylated keto sugar. This one is phosphorylated aldo sugar. You see? Therefore, it is possible to convert this into this and this into this. This step is considered as the 5th step in glycolytic pathway. That means conversion of glyceraldehyde 3-phosphate into DHA, dihydroacetone phosphate, or vice versa. And there is enzyme involved here. This enzyme is known as triose phosphate. It is processing isomerization, isomerase. Triose phosphate isomerase. Therefore, we have it is reversible reaction catalyzed by isomerase enzyme. And you know, the next step, which is this is step 5 of glycolysis. After step 5, we will have the 6th step. The 6th step uses only one of these isomers produced in the 4th step. Glyceraldehyde 3-phosphate is used to run the steps starting from 6 to the 8. Therefore, you can see that glyceraldehyde 3-phosphate obtained from step 4 and proceeds the next step. That is reversible reaction. Step 3, glyceraldehyde 3-phosphate. Now we count this. We do have 2 molecules, 1 molecule of this and 1 molecule of DHA. Since the 6th step uses this one, the enzyme that we use in the 6th step uses this one, step 6, the equilibrium will shift toward this glyceraldehyde 3-phosphate, so that the whole of this is converted into this one, so that starting from 6, the step 6, we have to multiply this product by 2. Because we don't have enzyme to catalyze this further into production of pyruvic acid. This enzyme, which is known as glyceraldehyde 3-phosphate dehydrogenase, or we can abbreviate glyceraldehyde 3-phosphate dehydrogenase. This enzyme uses as substrate only this substrate. So it will not use this one, consume this one. When this is consumed, the equilibrium will shift towards conversion of this. Then the next step is using this and converting to the next product. And the next product, this product also adds inorganic phosphate. Also, this is involved, that is NAD plus, of course, 2, 4, 2, 2. Let me cancel these 2 and we do it by 1 glycerol 3 phosphate, so that finally we multiply everything by 2. NAD H. NAD H is produced from 1 glycerol 3 phosphate. We add 1 phosphate at carbon number 1 of glycerol 3 phosphate, so that we will obtain 1,3 bis phosphoglycerate. The next product, the product of step 6 is this. We are adding 1 phosphate at carbon number 1. We are doubling it. Then the enzyme is, this enzyme is catalyzing the process, and then we are, dehydrogenation is there, therefore we produce 1 NADH at this 6th step. And the enzyme we have already told, and the process irreversible. Reversible. Then this is step 6. The next step is step 7. You see? So far, the pathway is not producing energy. You can see it. The pathway is not producing energy. Just we have used 2 ATP molecules, step 1 and step 3, investment phase. The specific step 4 is considered as the cleavage stage, because 6 carbon compound is split into 3 carbon compound, and this step is some call it the oxidation state. Why? Okay, the step 6 is considered the oxidation, because you can see that glyceraldehyde 3 phosphate is oxidized into 1,3-phosphoglycerate, oxidized. It has given its hydrogen and electrons to NAD plus, so that NAD plus has been reduced to produce what? NADH. Therefore, glyceraldehyde 3 phosphate is oxidized and NAD plus is reduced. Therefore, they call it oxidation phase. Step 6 is oxidation phase. Step 4, cleavage phase. Step 1 to 3, investment phase. Yeah, you can see it. Step 1 to 3, investment. The cell has invested 2 ATP molecules in order to bring glucose, energize glucose, and spontaneously break down to release energy. Therefore, hereafter, step 7 to step 10, the last step, it is a payoff phase, the payoff. Now, the pathway starts to pay off, produce energy, surplus energy. The investment is now generating energy. I will show you that step 1 to 3, investment, number 4, cleavage, specific cleavage. It is the stage or the state at which the term glycolysis is derived. Glycolysis means splitting sugar into 2. Cleavage, just breaking into 2. Of course, identical or different, but identical isomers. Cleavage. And step 6, oxidation phase. Oxidation. What is oxidized? Glyceraldehyde 3 phosphate is oxidized into 1,3-bisphosphoglycerate, but NAD plus is reduced. Therefore, we have this energy. The energy reduced coenzymes are energy as far as the process is aerobic. Okay. Now, the second product is here. Look how this molecule is generating ATP. ADP enters and ATP is produced now. It is starting to give us